So what we're going to do today is as follows. I'm going to take 5 Linux machines and I'm going to install Ansible Tower on them. And when I install Ansible Tower, I'm going to do it a little different than I would normally do, because I'm going to expose the Tower UI and API over port 80 instead of 443. We're going to assume that the network that the UI and the API are exposed to is trusted. And we're going to put a load balancer in front of those Tower machines, and the load balancer is going to offer a port 443 and SSL encrypted ingress to the Tower machines. So the load balancer is going to offer SSL encryption. The Tower servers themselves are going to do normal HTTP traffic, not encrypted. This is the way HAProxy performs best, so we're going to do it this way. What we're also going to do is we're going to configure these Tower systems to perform best and to behave in the best possible way according to best practices, at least that I know of, for an Ansible Tower cluster behind a load balancer. And one of the things we're going to do there is we're going to set up a private network on a secondary interface on all of these machines, and we're going to use that for the WebSocket broadcasts that are going to happen between these Tower nodes as they execute playbooks. We don't want to do that over the interface that offers the UI and the API because it's going to be a little chatty. So we're going to do that in a separate private network. So let's switch over to the machines. So let me show you the HAProxy configuration first. I'm using HAProxy as my load balancer because I simply don't have an F5 in my home lab. But what I do have is HAProxy running on a RHEL 8 machine. It's really very simple. Just DNF install HAProxy. You put a configuration file in place that is quite similar to this one. I'll put this one up on the blog later on so you can copy it and adapt it to your needs. I'm going to set the default mode of the load balancer to HTTP because that is what I'm using for the backend. All of the Tower servers are running on port 80, so that's easy. And I'm adding this specific option forward 4 because that's a header we're going to need later on when we set up the proper forwarding configuration and response configuration on the Tower side. I will show you a little bit of the statistics later on if we have time, and this is the backend we're using here. 5 Tower systems listing on port 80, each one of them, with a weight of 6 for Tower 1 and a weight of 1 for the rest of the machines, so we can actually see that Tower 1 will get a little bit of extra traffic as compared to 2, 3, 4, and 5. And finally, obviously the load balancer is going to listen on port 443 because this is SSL, and I'm passing it a self-signed certificate, so we can actually test that. So now we are on my Tower 1 machine, which is the system that I'm going to use to actually set up the Tower cluster itself. So we're going to have a database, which is not highly available, and then 5 Tower machines to spread the load that comes in through the load balancer. What we are going to do here is deploy Tower, but we're going to do a little bit of a customization in the inventory file that goes with the Tower setup. So if you look at the top bit here, where in the Tower section, you'll see that I have Tower 1 through 5 added, and I've added for each of them a routable hostname pointing to an address in the 10.0.10 address space. Looking at my network configuration here, you can see that I've actually got 2 interfaces. This is the primary one. This is the one that the Tower UI is going to listen on. And then here we have the address in the 10.0.10 address space, which is where the private network that I talked about earlier, which is where the WebSocket broadcasts are going to take place. The only thing we have to do for that right now is to make sure that the inventory specifies both the hostname here and the routable hostname over there, and then we can execute the Tower setup command, which I'm going to paste in here in a second. And we're back, I hope, or else I have to. All right, so I'm pasting in the install command right now. I'm going to tell it to run on port 80, which is another specific parameter you need to pass it. If we do not pass this specific parameter, everything is going to run on port 443, and we can load balance over port 443. But from what I understand, the way HAProxy works best if it can load balance over systems that listen on port 80. So we're going to pass it the nginx disable HTTPS flag, and we're going to do --space-b to enable the become functionality in Ansible. So I'm going to hit enter, and then we're going to pause a bit because it's going to take a while. But just real quick, while the tower installation is running, that's going to take a while because, installing over 5 machines. I will give you an update of how long that took when it's done. I don't know yet at this point. Currently behind me, you see the web page that is currently being served out by the HAProxy instance, giving me a 503, which is expected because none of the tower services that form the back end of this load balancer are currently running. They're still being installed. And later on, when we refresh this page, when everything is done, we actually see the tower interface coming up behind me. Back to the console. So here we are, back at the installation screen. The actual installation took about, 20 minutes? Probably because I'm running the whole tower infrastructure on VMs on my workstation. So there's a little bit of storage congestion going on there. Let me switch to a different terminal and we can go through some of the specifics. As you can see, let's check that first. What is listening currently on this system is not happening on port 443. So that worked. I got everything on port 80, and the Nginx process here is the actual tower UI. So that is all good. So that's perfect. But you can also see, if I look at the tower logs here, you will see that I have a couple of broadcasts that cannot connect because they're still trying to connect to port 443 here. So we're going to fix that in a second because we want those broadcasts to happen on that private network over port 80 as well. Let me switch over to my browser real quick. There we go. And I can hit refresh now here. That is F5, there's F5, there's F5, and we'll see the tower UI. So that bit at least worked. Now I have, switching back to the terminal, I have on this system a prep playbook. Actually not prep, it's post, whatever. And in that playbook, I can show you, I'm going to do a couple of things. First of all, I'm going to write a custom.py configuration file to etctowerconf.d, which contains a couple of lines of configuration. First of all, we're going to set the WebSocket protocol to port 80 over HTTP, and I'm going to set some forwarded host flags, which have to do with the interaction between the load balancer and the tower cluster behind it. I'm not going to explain it in a lot of detail. I don't have time for that, but the links mentioned here, and I'll put this whole playbook on the blog. You can read these links, and what is used here in terms of X-forwarded port and X-forwarded host is perfectly explained in these 3 links. What else are we going to do? We're going to apply a set of remote host headers that also have to do with the proxy configuration, which are configured here. The default is to have remote adder and remote host, and we're going to add HTTP X-forwarded 4. That is why, if you remember, I set the option forward 4 option in HAProxy. This is why. Because we want to have visibility on the originating IP address on the tower system, and we don't want to see the IP address of the HAProxy system in the logs only. There we're going to set the correct tower URL. If we send out notifications from tower, we don't want to have those notifications to refer to tower 1 or tower 2 or tower 3. We want them to refer to the name of my load balancer. People go to the right place, and there are various other settings in here as well. Now, I can run this playbook. I'm going to specify it like that. Ansible playbook. I'm going to pass the inventory, and we're going to pass it the name of the playbook here. And first, obviously, I'm forgetting this all the time, we need to install the right collection to do this because we are going to interact with Tower. So we want to install the Ansible Tower collection. I have configured my Ansible Galaxy command line tool to pull from Automation Hub. So this is a supported collection that I'm using here, perfectly tailored to work with Ansible Tower 3.8.3, and my playbook should work now. So there we go. Dropping in that configuration file, setting those headers, changing the base URL, and restarting every tower instance because we changed the configuration. And when I hit the logs right now, what we should see is that we can actually see that the broadcasts are succeeding here now. So connection from my system to another system now established. So the 5 towers are communicating over WebSocket broadcasts now, so that works. Switching over to the browser again, we can actually see that I can log in at this point with fabulous admin and a password. I now need to provide it with a subscription. So let me pause the recording here real quick. This is a bit boring. And we're back. And I've got the right subscriptions selected now. I'll hit submit and we'll get everything going from here. And when this is done, and this will take a couple of seconds, we can log in to the tower. We can go to instance groups. We see the tower instance group and we can actually see all the 5 tower nodes that I've configured earlier, and everything works fine. My whole tower system is set up to work perfectly. Now we can prove that by showing you the statistics, and I need to look up the specific URL for that, so let me hit pause again. Right, found it, so we can hit that URL and we can see that I've actually got the 5 tower instances listed here in my HAProxy statistics. And as you can see, you remember that I set up tower 1 to get a weight of 6 and every other tower instance to get a weight of 1, so they would get less traffic than tower 1. So that is actually exactly what is happening here. Tower 1 is doing a lot more than towers 2 through 5. So that is it. We got a tower cluster set up listening on port 80 behind a load balancer that is serving the tower UI over port 443 SSL encrypted. We got a private network for the WebSocket broadcast in the background, and we can use this cluster perfectly, because if one of these towers would go down for whatever reason, I could still access to the UI because the load balancer in front would detect that the tower is down and would not route traffic to it. So I hope this was useful. I hope to see you again in the future. And this was it for me for today. See y'all later.